Hey there, universe nerds. When we think about weather, we usually picture rain, clouds, or sunny skies. But beyond Earth, there's another kind of weather that can be far more dramatic and dangerous: space weather. This isn't about raindrops and snowflakes. It's about solar flares, coronal mass ejections, high-energy particles, and magnetic storms. Space weather is the invisible storm between Earth and the Sun, and it affects satellites, astronauts, power grids, and even the technology we rely on every day. The story begins with our Sun. The Sun is a giant nuclear furnace, constantly churning with plasma, magnetic fields, and energy. Sometimes, magnetic field lines twist and snap, releasing massive amounts of energy in the form of solar flares and coronal mass ejections, CMEs. A flare is a sudden burst of radiation across the electromagnetic spectrum, while a CME is an eruption of charged particles launched into space. If a CME is aimed at Earth, it can arrive within 1 to 3 days, slamming into our magnetosphere and triggering geomagnetic storms. These storms aren't just beautiful auroras in the sky. They can knock out satellites, disrupt GPS, interfere with radio communications, and even overload power grids. The famous Carrington event of 1859, the largest solar storm ever recorded, lit up the skies with aurora seen as far south as Cuba and knocked out telegraph systems worldwide. If a similar event happened today, it could cripple our internet, satellites, and global communications for weeks or even months. That's why scientists treat space weather as a serious natural hazard. But space weather isn't only about the sun. Cosmic rays, high-energy particles from beyond the solar system, also interact with Earth's atmosphere. Solar activity influences how many cosmic rays reach us, because strong solar winds act like a shield, deflecting some of them. During solar minimum, when the sun is less active, more cosmic rays penetrate Earth's atmosphere, increasing radiation exposure for high-altitude flights and astronauts. Space weather, then, is really a combination of solar storms and cosmic influences, woven into a constant dynamic background of energy. Monitoring space weather requires a global effort. Satellites like SOHO, Stereo, and the Solar Dynamics Observatory watch the sun in real time. Spacecraft like Discover and ACE sit between Earth and the sun, measuring the solar wind before it hits us. Ground-based magnetometers detect geomagnetic storms, while observatories around the world track auroras. Together, this network allows scientists to forecast space weather, giving airlines, power companies, and space agencies time to prepare. It's not perfect yet, but forecasting is improving. For astronauts, space weather is a very personal issue. Outside of Earth's protective magnetic bubble, radiation exposure is a real danger. A strong solar storm could give astronauts a potentially lethal dose of radiation if they're not shielded. This is one of the biggest challenges for long-term space missions to the Moon or Mars. Engineers are designing spacecraft with storm shelters, areas with extra shielding where astronauts can take refuge during solar particle events. Space weather forecasting could one day save lives beyond Earth. There's also an inspiring side to space weather. Geomagnetic storms produce auroras, those breathtaking light shows near the poles. Charged particles from the sun spiral along Earth's magnetic field lines, colliding with atmospheric atoms and lighting up the sky in greens, purples, and reds. To many cultures, auroras are mystical, symbols of spirits or omens. Science now explains them as particle physics, but the wonder remains the same. Space weather is both a threat and a source of natural beauty, reminding us how connected we are to the sun. Looking to the future, space weather forecasting will become as important as daily weather reports. With more satellites, more astronauts, and more dependence on technology, predicting solar storms will be essential. Missions like Parker's Solar Probe and Solar Orbiter are flying closer to the Sun than ever, unraveling its mysteries and improving our ability to forecast eruptions. One day, we may have hours or days of warning before a major solar storm hits Earth, enough time to shut down grids, protect satellites, and shield astronauts. So what is space weather? It's the constant stream of energy between Earth and the cosmos, from solar storms to cosmic rays. It's both a danger and a wonder. And it reminds us that our planet is not an isolated bubble, but part of a living, dynamic solar system. Every aurora you see, every signal disruption, every magnetic ripple is the signature of a universe that's alive with storms we're only beginning to understand.